Good day, everyone. Yes, Mr. Briggs here. So today's video will be based on a dynamic implementing a dynamic routing protocol, and that protocol will be RIP version 2. Now there are different dynamic routing protocols out there. You have the OSPF, EGIRP. You have ISIS, yes, and so forth. So with this video here now in mind, as I said, I'll be working with the RIP. There is a version 3 also. I think yes, a version 3 that's for the IP version 6, whereas RIP 2 is a more older dynamic routing protocol. Right. So looking at the diagram here, we have we have one network here, two networks here, three networks, four networks. Now what I did to save on time, I put in all the IP addresses for these interfaces, and this here, as you can see, I placed the IP address here so it could kind of give insight into what is happening here. This is the network here, the network IP. The net mask for each network is there, and as I said, the IP address for the interface. I didn't connect any computers because it became too cumbersome and the picture was kind of confusing. So to start with here now, each router here we want each router to be able to communicate with any router that is connected in this internet work here. Basically there's a connection, a network here with multiple routers. We have approximately 5 routers. Before I go further, what I'm going to say is that if you try to use static routing, you could, but it is going to be very cumbersome for such network. Even though it look like 5 routers, you will have a lot of routes you will have to be putting in and so forth. So we're going to use the dynamic routing protocol. So the first router we'll work with is, I'll use this one here. Alright, and with this router in mind here, we'll be configuring it via the real world scenario, not this. Well, I use the GUIs to put in the IP address, which was quicker than actually typing all the commands, but we are going to work with the real life scenario, which is how we actually configure a router, and this the screen that will actually come up with it. My bad, I just made a mistake here. This will just take a while to translate, but seeing it will take a while to translate, I will open up another router. So I'll go to this router here. So the first thing we do, normally configure, we go in privilege mode and then we go into the configuration terminal, config, and then terminal. Right. So looking at this here now, we have how many networks connected to this router here. We have one network because every interface is a network. So this router only have one network currently. If I decide to connect other interfaces, those will come up as different networks. So to implement the RIP here, we go router RIP, then you put in the version 2, and then you put in the network. Now the network for here, this network here is the 192.168.20.16, and if you look at the IP addresses, you can see that it falls within the range of this network. The subnet mask, actually what it is saying is that okay, this network is counting in 16s. So the when you look at this address here, the last address in this network will be 31, and that will be the broadcast. The last usable IP address will be 30. Okay, so I'm gonna put in the network address here now, which is 192.168.20.16. okay. Oh, my bad, supposed to put in the word network. Okay, so that is in right now. What we can do now is do show IP route, and it wouldn't come up here as yet. Okay, well, we just see it's directly connected. So I'll go back to this router here now. Alright, this error is rectified itself. Go into privilege mode, configure terminal. This is just the shorthand of it. Then I will go network, no, my bad, router RIP version. I normally put V2, but if you press tab, you will actually where you get the full word version, and I just put 2. So the next network, this router only has one network, which is the 10.10.10.17. yeah, well, actually this network here, sorry, this is the interface, this is the IP address, but there's only one network it is directly connected to. So 10.10.10.16. okay. Oh my, I keep forgetting to put the word network, forgive me people. Right, so we are going to the router now that has the most amount of configuring to do, which is this router, because this router has 3 networks, one here, and one also on this end here. So to configure it now, we go back into this now, privilege mode, then we go to configure terminal, and then we go to we put in the router RIP protocol, we enabling the router RIP. So we have router RIP version 2, then we go network. You see, we enabling RIP for each interface, so that when the packets come, the router can say, okay, this is encapsulated using well, you have the RIP encapsulation, the dynamic routing protocol, and it's like, okay, I understand what this is, so it will forward the packet. Now if I send a packet up here encapsulated in like in RIP, and then for instance the router doesn't have anything that could connect to this one here within that is reader that can read RIP, it will be like, okay, I don't know what to do with this, I really don't understand this packet, and it will just drop it. So you're gonna put in the networks. The first network will be the 10. I'll put in the 10.10.10.16. I'll do the network for the 192.168.20.16, 192.168.20.16, and then I'll do the network for here, the 172.16.20.64. so 172.16.20.64. right, now what I'm gonna do, I'm gonna run a ping test. I'm gonna use this router to try and ping across here, but before I do that, I'll do a do show IP interface, do show IP route, and we can see all the interfaces that is directly connected. Nice. So what I'll do here now, I'll go by this router, I'll do a do show IP route. Right, so as you can see here now, RIP is fully implemented, because we have the R here, which is the stating RIP, as you can see here, and what this is stating is that, okay, I am directly connected to this network via this interface. So what this router is saying is that, okay, in order for me to get to the 172.16.20.64 network, I have to go through this interface here, which is the 192.168.20.17. that is why you have it here, the 172.16. Well, basically what it did, it summarized everything here into a class B, a private class B IP address. It summarized everything. Now if I had put in the command no auto summarization, it would have given the specific subnet here, the specific subnet, but it summarized it, and basically this is the administrative distance, and it's telling you how, via how. So if I try to ping this network here now, if I try to ping, do ping 172.168.20.60, I'll do 65. okay, it should come up. Okay, it didn't come up. Make sure I placed in the right IP address, make sure that I have the correct stuff inside here. Oh, you see what happened there? I had the wrong IP address in. So basically that is what happened here. If I put 65, it should ping now. No, I put back in the 66. Sorry, it's supposed to be 66 because this is the interface here. So it's really supposed to be 66 here, 65 here. So let me try it again. It will work. 66, you see, it worked, because I end up mixing up the IP address, the labeling, because when you go into this interface and we look at the the serial interface 00. This one is 66. So by default, this one here, make sure I have everything in, this one is the 65 network. But you see, I would not be able to ping 65 because 65 doesn't have RIP enable on its interface. So when that packet comes across here, the router will be like, what is this? And it will just drop. It will just, you wouldn't get no reply. You will get that failure success rate 0/50%. Normally you will get 5 out of 5 or 4 out of 5. Okay, so what I will do now, I will go to this network here and I will run RIP on this network here, this interface. Configure, okay, router RIP version 2. And what I'm going to do here now, right, network, I'm going to put in the network here 172.16.20.64, right? Okay, now do show IP route. We should see all these RIP routes coming up because obviously the router broadcasts its information. So what this router is saying now is, hey, listen up, this router here, what he is saying is that I can get to this network here, or I can actually get to this router, to be more specific, if I want to ping it via this interface here on this network. So it should be the 172.116.20.66. and to show that it works, do ping to the 192.168.20.18 network, and we got a successful ping. So basically RIP is working here. This interface here it is working. Let me just review here. This network is the 10.10.10. okay, yeah, it is saying that we can get to this network also. So let me do another do ping. I'm gonna ping this router here, which is 17. Okay, let me see what's happening here now. Okay, we got a reply. So you see, we got the 4 out of 5. The first packet they dropped, we got the 4 out of 5, which is not bad. If you do it again, you will get a 5 out of 5. Okay, so we know for a fact that RIP is fully implemented here, is working here, RIP version 2. Now I can try just to make sure that everything is in functionality here. Do ping and make sure I can ping. That's what I do a lot. Make sure I ping that. Make sure I can ping the routers from a distance from the other networks and so forth before I proceed. So you see, we are getting ping. So this router can actually ping this router here. So what we are going to do now is implement RIP. Go back to this router here and implement RIP, because RIP for this network, because as it is here now, none of these routers can reach this router here. None of them. Just a quick reference, let me try something here. I will just go back here to do a quick ping test again. Yeah, ping is very critical. It helps to know where your connectivity is reaching, how far. So do ping 192.168.5.1. let me see. No, we wouldn't get a ping here. So okay, we didn't get a ping because, let me just verify why that didn't happen. Because on this router we only implemented RIP on this interface, so packets will come and it will reach this interface. After that, the router doesn't know where to send it, because the packets, okay, I have it in RIP, encapsulated RIP. Where do you send it? And let me clear something up. I think routing protocols are is like the way routers communicate. Yeah, that is the thing. Protocols, when you have a static route, you don't really, is not static route, is that you telling the router directly where to send this packet, where it will be going, and the routers now that is receiving it will get it and say, okay, let me assess, all right, you are going to this network. And that's what static routing do. Now static routing, the good thing about that is that once you put in that route, it will send it there. The thing with dynamic routing is that when you have things like RIP, and then RIP works with it goes by hop count. I couldn't remember the exact, I think it's up to 15 hop counts. After 15, the packet will drop. It would not reach its destination. So you have to have like 15 routers or less for RIP to actually function properly. Now the figure I'm giving here, it could be wrong and not too clear, but I think that is what 15 hop counts you need for RIP. The others now that use like OSPF, they go by like open shortest path. Well, yeah, they go by bandwidth, like bandwidth. OSPF will look for interfaces that have better bandwidth. You don't really study the distance. It will look for something that, okay, if you running at 10 megabit here, and we were running, if you were running at 10 megabit here, and then we had a next connection running from here to across here, and this connection was running 5 megabits, and here was running 100 megabits. Hey, let me tell you, OSPF will take that and it will go to the one with the best bandwidth and so forth. So let me just go back into this here now. RIP. We already have RIP implemented for this interface here, so I'm going to implement it now for the next interface. Router RIP. Oh, we actually in RIP already. We actually need RIP interface thingy here. So we go to network and we put in the IP address of the network, 192.168.5.0. Let me press enter, and we know, nice, we could reach this interface here. But let me tell you something, we still cannot ping this network. I will show you. Do ping, and we're going to ping this interface, the 192.168.5, that is this IP address for this interface, 5.1, sorry, and we will get a ping. Let us try to ping 2. Oh, this is this interface here. We're going to get some errors because this router sending a packet and this router doesn't know about this encapsulation RIP. So it's like, dude, and he just dropped that packet. So what we have to do here now, we have to go in this router here and enable RIP. So we go to the privilege mode, configuration terminal. Let me just spell it out for people, first timers. From here now we go to router RIP version 2, not versions, version 2. Oh my, I forget the S, sorry. Network. Oh yeah, so this router now is going to be like, oh man, cool, I am on the RIP network now with my other brothers and sisters, and voila, he's in. Now if we do the show IP route, you're going to see he's connected to everybody in this network. You can see he's connected to this network here, he's connected to this network here, and he's also connected to this network here, and he's actually showing you via the interfaces. So he's connected to this network via this interface, because that is where his exit, that is where his last connection is, that is where he knows about this router here. But after that now, this router have to take all this information and forward it to this network here. Okay, so we'll do ping, and we will just ping this network here, this right here, IP address, the interface 18, and we will get the successful ping. Just to do our inverse to make sure that everything is functional, do ping 192.168.5.2, and it works. So folks, basically that is it with RIP version 2. I will be doing other videos based on well, OSPF. OSPF is a nice network. It's a lot of, it's better than RIP. You know, it's convergence and all these other stuff. It doesn't do all the setup broadcasting like RIP. RIP will be like, okay, he have all this in his routing table, he's gonna broadcast it to everybody, and then this one is gonna broadcast to everybody, and then he's gonna broadcast. No, OSPF, you have like one router will just have all one router will have like it will be the router that holds the database description, and he now will update all the routers on his network with that, and all the routers on the OSPF must have the same routing table. So basically folks, this is my quick video on RIP version 2. I hope it was informative. Look out for more.